Okay, guys, 2.2 reasons for the seasons. I'm like a rapper. Okay, let's get started. Okay, so true or false? The earth is closer to the sun in the summer and farther in the winter. And that's what causes the heat in the summer and the cold in the winter. What do you think? It's false. It is incorrect. That is not right. Okay, and let's go over why. Okay, so write that down that is false if you don't know that. Okay, so now the sun is actually. So here, let's do a little. I think I actually got pictures. I got pictures. Let's do this. Okay, so the Earth goes around the sun in an oval. Okay, I'm gonna exaggerate this oval right here on a picture I'm gonna draw. Okay, so let's say the Earth. It does do an ovalish orbit like this, okay, and this is the sun, but it's nowhere near this bad. It looks mostly like a circle, but when you're closer to the sun, us on the northern hemisphere, we actually are having a winter. Yeah. So when we are closer to the sun, we're actually in winter, and when it's further away from the sun, we're actually in summer. Okay. So then that means that the seasons do not depend upon how close you are to the sun. So what in the world could the seasons depend upon if it's not your distance from the sun? So seasons completely depend upon the Earth's axis. I don't know why that big line got drawn right there. Okay, so the seasons depend upon the Earth's axis tilt. Okay, so remember I said we were tilted 23.5 degrees off of the like being straight up. And here you can see it right here like this. We're tilted 23 and a half, and we go around the Earth like that. So when the northern hemisphere is facing the sun, that's summer. Okay, so like look over here. The northern hemisphere would be mostly not facing the sun when you're in winter. Yeah, you're not gonna be getting direct sunlight the entire time like you do right here. Okay, and it's not from. I know it kind of looks like it's because you're on the dark side here. It's not because it's night. Okay, it's because here, watch right here is getting most of the sun on when it's tilted that way. The southern hemisphere is getting most of the sun. So when we are having winter, the southern hemisphere is having summer. Yeah. So when we are in the depths of like January and it's just freezing cold in like New York and here also in Brazil, it's super hot. Yeah, they're having their summer at that time. Okay, and the reason is because they're facing the sun more, and this is where we are up here, right? And we're not getting that direct sunlight like we were when it's over here. And then the spring and the fall, we get the same amount of sunlight in both the spring and the fall. Those two are the ones that are different, the summer and the winter, right? Okay, so let's go forward. Okay, now one thing that does happen though, which I did say, the Earth does get closer to the sun some times of the year than other times of the year. It happens to be our summer. Our summer is when it is furthest away, right? Okay, so this variation is about 3%. Okay, you probably don't need to know exactly 3%. You don't need to know the exact numbers of how far away we are when we're closest and farthest. But it's something that you should know is that we do get closer and farther away from the sun, but it does not cause seasons at all. Okay, I don't want you to think that that is causing any difference in the seasons. Okay, so next thing here. Okay, so this is it's called an analemma. Is the name of this little what do you call it? Figure. Okay, and here I can write analemma down. So if you are interested, you can write that down. You can Google it if you want. And what an analemma is someone basically goes outside, they post up their camera, okay, and they take a picture every day at 12 o'clock noon. It looks like this person took I don't know, probably a picture every a couple weeks or so. But they take a picture of every day at noon, and they put the camera in the exact same spot. And if you put these pictures together, this is where the sun is at every day at noon throughout the year. Notice it's drastically different. Okay, so the sun is the highest in the summer. I mean, which would only make sense. At noon in the summer, the sun is going to be the highest. So you could probably guess what it is all the way over here when at noon the sun is the lowest in the sky it'll be throughout the year, and that is in the winter, right? And just so you get an idea of where this picture is being taken, it has that saguaro cactus, so that means that it is in Arizona. So it's probably about the same altitude or latitude as us in El Paso. It's right about the same. So this is what the analemma would look like if you were to go outside and take a picture with your camera every day at noon for the whole year. Okay, and then you like combined all your pictures. This is what it would look like here in El Paso. Now, this right here where they kind of intersect, this is called the equinox. And that's when spring and fall happened. Okay, you got the fall equinox and the spring equinox. And I'm writing really slow because this app, the PowerPoint, only allows me to write slow. So you have the fall equinox and the spring equinox, and then you have the summer solstice. And my computer's now starting to freeze on me. So solstice, and you know what? I'm not even gonna write it because it'll be on the next slide. Okay. So you got the summer solstice and the winter solstice as well. Okay. So we call the equinoxes because that's when they are the same. As you can tell on here, that's where they intersect. All right. And then you got the solstices where they are drastically different. Okay. Let's go forward. And here you go. So here's basically when those things happen, okay? So the summer solstice happens usually around June 21st. It's not exactly June 21st every year, okay? It might be like the 22nd or it might be the 20th. But that's when the sun is the highest in the sky that it will be that year. And you might ask, like, well, why would it change? Well, remember, we have leap years, right? Because 1 year to go around the sun does not take 364 days, and then like every 4 years it just skips, it makes an extra day. No, to go around the sun once fully takes 364.25 days. Okay, so that's why every 4 years we have an extra day that we add on to make up for that day, that quarter of a day we're not counting every year. Okay, so we got the summer one is right then. The winter one is about December 20th or so, solstice. The spring and falls are in March and September, okay? And they're usually around like the 20th as well. So you're going to want to write those down. You're going to definitely want to know what the summer solstice is, the winter solstice, and what the spring and fall equinoxes are, okay? So summer solstice is when the sun is highest in the sky, winter solstice when it is lowest in the sky, and spring and fall when they are the same. Now, there's a better way to describe these, and I think I have them written over here. Yes, so here's the actual definitions here. So like I said, summer solstice, highest path the sun takes in the sky. Winter solstice, the lowest path the sun takes in the sky. Equinoxes, this is one that you need to write down. The sun rises exactly, so precisely, due east and sets in the west, okay? So you guys have learned, and we've said in the last one, that the sun rises on the east, sets in the west, right? Okay, well, it always rises close to the east and sets close to the west. The only time it rises exactly east and sets exactly west is on the spring and fall equinox. Those are the only times where it actually comes up right at the east and sets right at the west. Okay? Last thing we need to go over on 2.2. Okay, so I told you guys that we have a, I'm trying to get my little thing so it doesn't block any pictures here. We sit on a 23.5 degree axis tilt, okay? And right now, that axis tilt, if you look at the north celestial pole, which we spoke about on the celestial sphere, right above the North Pole, if you follow it, we have the North Star, which we call Polaris. And as we spin and spin and spin, that star does not change where it is in the night sky. But all other stars do, right? They all move in the night sky. This is the only one that does not. And that's the Northern Star. Okay, well, that's only for us right now. Okay? In a few thousand years, that North Star is not going to be the North Star anymore. Because what happens is we have a 23.5 degree tilt, and we kind of move around like a top. I don't know if you've ever spun a top, like this is a top. What happens is it's spinning, and once it starts to kind of lose its spin, it starts doing a wobble. Okay, that wobble is called precession. Okay, so it's spinning, it's spinning, it's spinning, it's spinning, but it's wobbling. Okay, and we're doing the exact same thing, except we have an extremely long period of time to wobble. Yeah, so like what you would call like one full circle of a wobble, that's called a precession. Okay, that's called a precession. And I thought I had it written. Oh yeah, I do right here. It precesses. Okay, so the Earth does that as well. And to go one full way around, one full precession, takes 26,000 years. Okay, so the North Star is Polaris right now. In 26,000 years, the human beings on Earth will say the Polaris is the North Star for them again. But if, let's say that, cut this in half, 13,000 years. In 13,000 years, the humans that are on Earth will not be looking at the North Star to be Polaris, but they will be looking over to the other side of the sky, and it will be Vega. Okay? So our North Star changes over time. Now, it's not going to change over our lifetime because we precess at such a slow rate. So our entire lifetime, unless you're a vampire that can live a very long time, the North Star will always be Polaris. But that will change for future human beings. And human beings, Homo sapiens, have been on Earth for about 200,000 years. So there's been about nine generations of human beings that called Polaris the North Star, right? There's been about 9 that have called it Vega. Okay, so we've been through this precession, and humans have seen it, yeah, over time, except it's just happened over such a large generation of people, ancestors, and we didn't really, I don't think that they probably spread that through story. It's something that we discovered through science, okay? Something very cool. Okay, so let's see, I have one more thing here. So remember, the tilt remains at 23.5, but we persist around, and it takes 26,000 years for one precession cycle. Okay? And that's it for 2.2. I hope you enjoyed.